Welcome to sixth grade math. That was your homework that was due today. Get ready for the lesson. Art supplies. A box contains some crayons. There are also 2 crayons outside the box. The total number of crayons is a sum of 2 and some number. The 2 crayons outside the box represent the value 2, and the box with the remaining crayons represent the unknown value, some number. What does some number represent? Total number of crayons inside the box. Find the value of the expression, the sum of 2 and some number, if some number is 14. So if we add 2 and 14, which represents some number, we get 16. Assume you have 2 boxes of crayons, each with the same number of crayons inside. Write an expression that represents the total number of crayons in both boxes. So we have 2 boxes with 14 crayons inside. So we have 2 times some number. What does that mean? There has to be an easier way to say this. There is. We can use algebraic variables and expressions. Algebra. A language of symbols, including variables. The important thing to remember is math is a language. Variable. A symbol, usually a letter, used to represent a number. Everyday use, variable means able to change and vary, as in a variable wins, so wins to change speed, maybe direction. And then math use, symbol used to represent a number. Algebraic expression are combinations of variables, numbers, and at least one operation. The letter X is often used as a variable. It is also common to use the first letter of the value you are representing. Let's look at the previous example with crayons. 2 plus some number. Some number can be written using n for number. 2 plus n. They told us some number was 14, so n equals 14. 2 plus 14 equals 16. Any letter can be used as a variable. The letter X is often used as a variable. It's also common to use the first letter of the value you are representing. In the last example, we could have used C to represent crayons. I know that's a little repetitive on this slide, but I think it's worth hearing a couple of times that the variable that you use doesn't matter, and you can use any number of variables. Variables in an expression can be replaced with any number. Once the variables have been replaced, you can evaluate the algebraic expressions. Evaluate is when we find the value of the algebraic expression. In addition to the symbol x, there are other ways to show multiplication. 2.3 is 2 times 3. It's the same as 2 with the x for the multiplication sign. 5t is 5 times t. So if we put the coefficient right up against the variable, it's multiplication. And then st is s times t. Scaffolding questions. How do you say the following algebraic expressions? Y minus 8. 7 times a. 4 plus m. 2 times x plus 5. How can you find the value of the expressions? You need to know the value of each variable to find the value of each expression. When a plus sign or a minus sign separates an algebraic expression into parts, each part is called a term. Examples. Evaluate algebraic expressions. Evaluate 16 plus b if b equals 25. So we have 16 plus b, and we're going to replace b with 25. So we have 16 plus 25, and if we add those together, we get 41. Evaluate x minus y if x equals 64 and y equals 27. So we have x minus y, and we're going to replace x with 64. So 64 minus y. Now we'll replace y with 27. So we get 64 minus 27. Subtract 27 from 64, and we get 37. Evaluate 5t plus 4 if t equals 3. 5t plus 4, replace t with 3. We get 5 times 3 plus 4. Add 15 plus 4. Well, first we multiply 5 times 3, and we get 15. Then you add 15 plus 4, and we get 19. Check your progress. Evaluate each expression if a equals 6 and b equals 4. So a plus 8, replace a with 6. 6 plus 8, add 6 and 8, and we get 14. A minus b, replace a with 6. We have 6 minus b, replace b with 4. 6 minus 4 equals 2. A times b, replace a with 6. Get 6 times b, replace b with 4. We get 6 times 4. Multiply 6 times 4, and we get 24. 2a minus 5. Replace a with 6. So we get 2 times 6 minus 5. Remember, when the number is right next to the variable, it's multiplication. Multiply 2 times 6. We get 12 minus 5. Then if we subtract 5 from 12, we get 7. Test example. An expression for finding the area of a triangle that has a height of 3 units longer than the base is b plus 3 times b divided by 2, where b is the measure of the base. Find the area of such a triangle with a base 8 units long. All right, so we're just going to plug in. I know it's a lot right there. But let's just break this down into pieces, right? And they've given us the formula that we need. So all we need to do is, and not only have they given us the formula, they've given us what b equals. So all we have to do is substitute 8 in for b. So if we put 8 in for the first b, we get 8 plus 3 inside the parentheses. And then if we put in 8 for the second b, we get 8 divided by 2. Now we're going to use PEMDAS to evaluate. We're going to do parentheses first. So 8 plus 3 is 11 times 8 divided by 2. And we're going to use PEMDAS again, and we're going to do the multiplication next. So that's 88 divided by 2. And then there's only one operation left, so we'll do that next. 88 divided by 2 is 44. So the answer is C, 44 units. Check your progress. If admission to a fair is $7 per person and each ride ticket costs $2, the total cost for admission and T ride tickets is 7 plus 2T. So that's $7 plus $2 for every ticket. Find the total cost for admission and 5 ride tickets. So we know the formula is 7 plus 2T, which means $7 plus $2 times the number of tickets, which is T. And then they're going to tell us T equals 5. All we have to do is substitute, replace that T with a 5, and then we just have to do the math. So PEMDAS tells us that multiplication comes first in this problem. So we have 2 times 5 is 10. Then we're going to add 7. 17 is the answer, and it's G. All right, we're going to look at a couple of formulas that you're going to see tonight. You don't have to memorize them, but I want you to be familiar with what they stand for. So they're distance rate time formula, D equals R times T. D equals distance, R equals rate, and T equals time. I just wanted you to be familiar with that. And then the other one is the formula for the area of a rectangle. A equals LW. A equals area. L equals length, and W equals width. So just so you know when you see those tonight, what those stand for. And here's a little challenge to think about. Are 4x squared in parentheses 4x squared equivalent? And what I mean is, are they this? If you were to solve for these two, would they be equal? So let's take a look. 4x squared equals 4 times x times x. Do you think that's what parentheses 4x squared would look like if it was factored? 4x squared equals 4x times 4x, or 4 times 4 times x. So it's not exactly the same thing, is it? It's actually not even close to the same thing. Remember, the parentheses groups the 4 and x together, so the exponent outside of the parentheses, it applies to everything inside the parentheses, whereas the first one, the 4x squared without parentheses, because there aren't parentheses, that exponent is only applied to the x. So those are not equal, and that sign, the equal sign with a slash through it, means not equal. There are other ways to show multiplication other than using x. This is especially important in algebra where x is often used as a variable. So if you're using x for a multiplication sign, it can get confusing when you're using x for variables as well. So 4x means 4 times x. 4 dot x means 4 times x. And 4 parentheses x means 4 times x. Additional examples. Evaluate 20 plus c if c equals 5. So we have 20 plus c, and we need to replace c with 5. So we get 20 plus 5, and then if we add, we get 25. Evaluate p minus q if p equals 14 and q equals 13. P minus q, replace p with 14. So we have 14 minus q, replace q with 13. We have 14 minus 13. Subtract 13 and 14, and we get 1. Evaluate 2x plus 3 if x equals 4. 2x plus 3, replace x with 4. 2 times 4 plus 3. Multiply 2 times 4 because of PEMDAS. 8 plus 3, and we get 11. Test example. The amount of money Sabrina will need to pay for 5 binders using a $2 coupon can be represented by the expression 5x minus 2, where x is the cost of each binder. Find the amount of her purchase if each binder is $4. So we're going to use that formula, 5x minus 2, where we're buying 5 binders, and the cost is x, which they've given to us at $4, and then minus 2, which is the $2 coupon. So if we substitute the 4 in for x, we get 5 times 4 minus 2. And we're going to use PEMDAS to evaluate, and that's going to be multiplication comes first. So 20 minus 2, and then 18 is the answer. Okay, here's your homework for tonight. So head on over to your Google Classroom to fill that out. Thank you and have a great night.